Okay, we have a few more examples to get through. This one is going to be a similar approach. Notice that one equation is solved for y and the other is not. So that's your clue to look for to use this method where we're going to take the value of y, or the expression for y, and substitute it into the first equation. So I'm going to have negative 2x minus, and in place of the y, I'm going to put negative 4x minus 7 equals 5. Now this one's a little different. You have to be careful because it's as if there's a negative 1 right here. So you can kind of envision that, and you have to distribute that to the parentheses. So it's very important that you put parentheses. As a matter of fact, whenever I do this substitution method, I always use parentheses, and then hopefully you'll remember to distribute the negative sign. So we have negative 2x. A negative 1 times a negative 4x makes that a positive 4x, and that's going to make this a plus 7. Again, these are on the same side of the equal sign, so we just combine like terms. We get 2x plus 7 equals 5. Subtract 7 on each side. We get 2x equals negative 2. Divide both sides by 2, and we get x equals negative 1. Notice how I went from step to step without showing what I'm doing on both sides. You can do that way. Just show one step at a time without showing what you're doing. That's okay. If it helps you to put the little minus 7, then by all means you can do that. Now that I know x, I still have to find y. So I'm going to take that and substitute. I could substitute it into either equation, but this one's easier because it's already solved for y. So I get 4 minus 7, which is negative 3. So then my solution is negative 1, negative 3, which means if I graph these two lines, this is where they cross, and this is called the solution to my system of equations. All right, notice on this one, little different, neither one is solved for a variable. Now I'm going to take a look though at this first equation and look how easy it would be to get the x by itself. If I add 3y to both sides, I would get x equals 3y plus 10, or you could say 10 plus 3y, it wouldn't matter. But now I can take this expression for x, now this time it's for x and not y, so I'm going to plug it in right here. Not a very good arrow though. So I'm going to take this and plug it in for the x in my other equation because this one was solved for x. So I get negative 2, and in place of the x, I'm going to put 3y plus 10. Then I have minus 3y equals 7. Distribute. We get negative 6y minus 20 minus 3y equals 7. Again, these are on the same side of the equal sign, so I combine and I get negative 9y. And I'm going to go ahead and add the 20. So I get negative 9y equals 27. And when I divide by negative 9, I get y equals negative 3. Again, I'm not done yet. I need to take this answer and substitute it in and solve for x. And you actually can plug it into the one that was rewritten. So x equals 3 times negative 3 when I substitute, plus 10. So I get negative 9 plus 10, which is 1. So my solution, make sure you put the x first, is 1, negative 3. This is a similar problem, so take a look here and ask yourself which variable would be the easiest to solve for. Definitely not this one, because you've got a value in front, a coefficient. This, because the x's are both negative, the easiest would be to solve for y. So I'm going to do that by adding x to both sides, and I get y equals x plus 1. Now I'm going to take that and substitute it in place of the y for the other equation. So I get negative x minus 2, And in place of the y, I'm going to put x plus 1 equals 10. Distribute the negative 2. And again, it was a negative, so we do have to distribute. We get negative x minus 2x. That's going to make this a minus 2 when you distribute the negative. Again, these are on the same side, so we get negative 3x. I'm going to go ahead and add the 2. So negative 3x equals 12. So x equals negative 4. Remember, we have to still solve for y. I'm going to put it into this rewritten equation. So y equals negative 4 plus 1, which is negative 3. So my solution is negative 4, negative 3. All right, same situation here. If you, as a matter of fact, I'm going to go ahead and skip this one. And we'll move on to the next problem. All right, so let's try this one. Now notice I have one equation already solved for x. So I'm going to go ahead and make that substitution right here. And when I do that, I get 2 times 2 plus y plus 3y equals 5. I'm going to distribute the 2. We have 4 plus 2y plus 3y equals 5. I'm going to have a 5y here. I'm going to go ahead and subtract the 4 from both sides. Now notice here I need to get the y by itself, so I have to divide by 5. And I get y equals 1/5. Oh, not so nice of an answer, but that's okay. You can get answers that are fractions or decimals. As a matter of fact, if you did this as a decimal, you would get 0.2. So now I'm going to substitute x equals 2 plus 1/5. I'm just substituting that back into the first equation. So we get x equals, and you could say 2 1/5, or you could say 11/5. So my solution is 11/5, comma 1/5, and that would be where these two lines cross. Okay, let's try this one. This one's going to be a little surprising solution. I already have one of them solved for y, so I'm going to substitute it in here. When I do, I get 8x minus 6 equals negative 3. Remember, this is like having a negative 1 there, so we are going to have to distribute that minus sign. We get 8x minus 8x. It's going to make this a plus 6 equals negative 3. 8x minus 8x, those cancel out. So we have 6 equals negative 3. Well, wait a minute. You guys know that's not true. It's never true. So our solution actually is no solution. So when you get a statement that's never true, then your solution, you would just say it's no solution. And for our final example, another special case. Again, this one's already solved for y. I know you're looking already and saying, ah, fraction, but it's not a big deal. So I'm going to substitute. I'm going to have x plus 2 times negative 1/2 x minus 1 equals negative 2. And I'm going to need to substitute, or I'm sorry, distribute the 2. So when you have 2 times a half, think of what's half of 2. Remember, this is like 2 over 1. So the 2's cancel, and you're going to end up with negative 1. And if you just think about what's half of 2 is 1. But since one of them's negative, we have negative 1x minus 1 equals, I'm sorry, let's get rid of that real quick. Forgot to distribute 2 times negative 1, so we have negative 2. Well, here again, the x's cancel. X minus x cancels. So I get negative 2 equals negative 2. Well, that's always true, which means there are infinite solutions. Which means if you graph these two equations, these are the same line. And remember, we had a name for that. That meant that this was consistent and dependent when we had the same line. As a matter of fact, let's look back at this one. When there's no solution, that means they don't ever cross. That meant that these were parallel lines, because if they never cross and they're in the same plane, they must be parallel lines.